Hey guys! So classmate asked, what are the different parts of the potential energy diagram that we need to know for the chemistry subject SAT? Before we begin, let's first understand what is a potential energy diagram. Potential energy in this case refers to the energy stored within the bonds of chemical compounds. A potential energy diagram plots the change in potential energy that occurs during a chemical reaction as reactants are converted into products. Therefore, the diagram has the progression of the reaction plotted on the x-axis and the potential energy on the y-axis. But what can this diagram tell us about our reactions? As a whole, the potential energy of the products is the energy shown by the distance of the rightmost horizontal line and the x-axis, while the potential energy of the reactants is the energy shown by the distance between the leftmost horizontal line and the x-axis. However, potential energy diagrams can represent two different types of reactions: endothermic and exothermic reactions. In an endothermic reaction, the energy of the products is greater than the energy of the reactants, as shown in the first diagram. While in an exothermic reaction, the energy of the products is lower than the energy of the reactants. The difference in potential energy between our products and reactants is our change in enthalpy, denoted as delta H, which is positive for an endothermic reaction and negative for an exothermic reaction. Remember that enthalpy is the thermodynamic property that is equivalent to the total heat of the system. This makes sense, since we know that in an endothermic reaction, the process will absorb heat from its surroundings, allowing for the potential energy of our products to be greater than that of our reactants. However, in an exothermic reaction, the process will release heat into its surroundings, causing the potential energy of our products to be less than that of our reactants. Another important part of our graph is the activation energy, also known as an activation energy barrier, which is illustrated in the potential energy diagram by the height of the hill between the reactants and the products. Essentially, it's the difference between the potential energy of our reactants and the maximum energy plotted. In order for a reaction to occur, reacting particles must have enough energy so that when they collide, they can overcome the activation energy barrier that is shown within our graph. The larger that barrier, the more energy is needed for a reaction to occur, making it more difficult to create our products. If we were to add a catalyst to our reaction, then the reaction would be able to proceed faster, since it lowers the activation energy of our reaction. This means that less energy is required for reactant particles to overcome, since a smaller hill means a smaller barrier. I hope this video helped you to understand the basic parts of a potential energy diagram and its relationship to endothermic and exothermic reactions.